Our next presentation is Inside Google Peering, Trends, Recent Policy Changes, and Future Direction. Our next speaker is Dave Schwartz, who will be presenting the aforementioned presentation. Dave is a product manager of Peering and Internet Edge at Google and traveled to us from Los Angeles today. This is David's first time presenting at NANOG, and it's a pleasure to have him speaking with us today. With that, welcome, David.
All right, thanks for the introduction, Steve. And good afternoon, everybody. I'm Dave. I'm the Peering Product Manager at Google. And I'd like to share a little bit of the updates on our policy changes, what we observed and what comes next. There we go. And also just a shout out to Gemini for giving me a slightly catchy title for the presentation. So, why are we here? Is a talk like this even still relevant? We've made a lot of changes to our policies over the last 10 years and many more over the last 2. And we haven't really shared them at a forum like this, and most people have probably experienced them as a website update or an automated email, but nothing really in person. And we're obviously a large part of the community, so we want to share more on the specific change. So we'll take you a little bit on the journey of how we arrived at where we are today. So let's go back a little bit to 2015 to see what was happening then that will help set the stage. So YouTube traffic was growing double digits year over year. There was no premium YouTube offering, it was ads only. Search and ads also continued to grow in traffic and revenue. Google Cloud was also very new. App Engine only became generally available in 2011, and Compute Engine, which is our VMs, in 2012. So what did that mean for our peering and connectivity? Well, we were very open. We were willing and often desired to peer with everybody, everywhere, with as much capacity as possible. And given the rates of growth, having more was always better than coming up short. Similarly, with our caching nodes, they were deployed very liberally and had very low traffic requirements for them. As part of that, our backbone 15169 was expanding to support all those products. So since 2015, we did expand to more regions across the world. So in summary, you can think about it as large product growth, an expanding network, and all the connectivity there was to support it. So let's fast forward 10 years to where we are right now. With respect to internet connectivity, cloud customers using our Internet Edge are now front and center. There's all manner of enterprises using our network for business-critical services, including front-end ingress load balancing, API calls, VPN tunnels, etc. And particularly for cloud customers running VPN concentrators in Google, they're doing and reselling full VPN tunnels to our network. So stable latency for those connections is crucial. And even minor fluctuations to that can cause challenges and then customer escalations. Search and ads, they remain very important to Google, but they're now largely stable in terms of traffic patterns. And after 10 years of expanding peering and GGC very liberally, we're connected to an increasingly large amount of networks worldwide. So, what does that mean for our peering today? Earlier this year, we updated our policy. We're a selective network only, and we're only turning up PNI peering on 100G ports. We're no longer turning up any new internet exchange peering, and we're no longer peering with any route servers. And contrary to some communications, we're not taking down any public peering sessions. Those will still remain. We also launched our verified peering provider program, and that encourages cloud customers to use what's essentially a well-peered ISP to reach Google instead of peering. And I'll share a little bit more on why. And most of our network expansion is now exclusively for Google Cloud. So we have regions that have VM to internet latency requirements, so we can achieve low latency to those users surrounding the cloud region. And we also stopped expanding YouTube to our new peering locations. So for example, Brussels was a new Internet Edge location that we built to support our cloud region, but it doesn't actually egress YouTube. And as you can see from the graph on the right-hand side, cloud traffic does continue to grow. So what happened between the first 2 slides that led us to change? So I'll talk about some examples that we saw. So the first one was about Inbound, unpredictable traffic on internet exchanges. So the diagram on the right shows a time when we saw sudden and persistent spike of cloud storage traffic to our network. Now, if you can imagine anyone else using that same port for ingress, they're going to see packet loss and they're going to see latency. And if those networks are cloud customers, that's a really very real problem for them since it's frequently business critical traffic. So during the time that image was taken, we had been peering with route servers, which actually amplified both the likelihood of that happening and the occurrences because we were sending our routes to many more networks. So we were more likely to see those types of traffic patterns. So even without the route servers, when things like this happen, many IX sessions becomes both operationally taxing for our SRE teams and for our teams that manage all of the IX relationships across thousands of networks worldwide. And at the end of the day, we look at this and we think this creates an experience risk for our customers operating on a shared fabric. So let's talk about mitigation and ownership of something like this. So when we see this, right now, it's generally up to Google to mitigate this, as the IX is a somewhat neutral party here. You know, when we mitigate it, it usually involves a drain of some sort. So we'll either drain the offending traffic or we'll drain the surrounding traffic to isolate that traffic. The problem is when we do that, we don't actually know where the traffic is going to be rerouted. Some IXs do have redundancy in the metro, but some don't. Are we peered with those networks? Will that traffic actually go there? It's a bit of a wild card, and that goes against our desires of having that stable internet latency for our customers. On the other hand, we've rarely seen events like this when this congestion is on a PNI to an internet service provider. And this likely points to the fact that some ISPs are responding and managing this congestion, versus waiting for Google since they kind of own that aggregation point. Also, when we mitigate this traffic surge on PNIs, we have a much better idea of where the traffic is going. And the reason for that is a couple of years ago, we started requiring redundant PNI connections to our network. And many of those ISPs now do have redundant connections in the metro. So when we TE, that ingress alternative path is known and it's likely in the same metro area, reducing the latency for our customers. So talking a little bit more about the latency fluctuations. So similar to what I was just talking about, here's another real world example of how like a cross-metro failover can actually impact a customer. So you can see on the graph, we had a customer who was running a VPN appliance inside Google Cloud. That means for all of their customers who were doing a full tunnel, this cross-metro latency is essentially added to their latency. This is because they tunnel all traffic into Google. Traffic then leaves Google, so their internet experience latency is added to the latency you see on the screen. So the customer understood where they were in LATAM, that it was about 100 milliseconds based on observed behavior. But we had a planned maintenance that rerouted this traffic very far away, almost tripling it in certain extreme cases. And then obviously it was a problem for the customer, obviously a problem for Google. So this was in LATAM, but we do see similar challenges both in Europe, in Asia, and even in the US at times. And this, when this happens, this impacts the perception of Google, particularly if there's a lot of cloud customers, in one certain geographic location. All right, let's talk about another customer pain point that we experienced, black holing from customers. So we do have a set of cloud customers. They do have an ASN, they have a presence at a colo facility, and they are peering with us. So during normal operation, everything works great, but when there's an outage, either planned or unplanned, the traffic will fail over to another metro. And that's assuming the customer is peered with us in another location and is announcing all prefixes. However, what we found out is that the customer actually experiences a black hole of that traffic during a failure. And when troubleshooting with them, we discover that they have firewalls sitting directly behind the peerings in all locations where they're peering, as you can see in that diagram. The firewall views that rerouted traffic as suspicious because it's asymmetric, and then it blocks the traffic. So that causes a customer black hole and all the customer frustration that comes with that. So to mitigate it, some customers have actually built a full mesh network in front of all of their firewalls so that the synchronous traffic is maintained, assuming it's an issue on the Google side. But that will allow the cross-metro failover. But again, this is another real-world challenge that a lot of enterprises who want to peer may not be familiar with the nuances of peering and failover, and it impacts their connectivity experience and then ultimately impacts their experience with Google Cloud. So, given everything I just said, all the challenges we saw, these were some examples, but these are kind of the themes we kept seeing year over year. What did we actually do? It's a little small, but I think people can see. So here's what we did in an attempt to mitigate all of that from actually happening going forward. And we've had a good degree of success with these changes over the last couple of years. So back in 2022, we required redundant PNIs for all ISPs, and that involved the policy change and lots of outbound communications to all of our peering partners worldwide. And again, the key point was to get that stable latency within a metro area during our planned or unplanned maintenances. We've actually been monitoring this very closely, and we've actually inverted the numbers with peering redundancy, so we've definitely seen success in keeping that stable latency during outages. Following that change, we did depeer all route servers, and then again, that was designed to mitigate multiple challenges we had over the exchanges, including what I mentioned about uncontrollable IX traffic. Route servers also did present an issue for BGP hijacks. And if you want more information, my colleague Arturo gave a very good presentation at EPF on some of the dilemmas and challenges that we had. And so since then, we've actually seen a large reduction on the inbound traffic on our exchanges. Following that, we started to look at some of our remote IX connections that were built in the early days of Google when traffic for YouTube was going year over year high digits. Now that our products have matured, we started asking ourselves, hey, did some of this expensive and pretty complex connectivity actually make sense? So we looked at all of our alternative paths, we looked at our product quality, we actually determined a lot of these didn't make business sense, so we exited most of those remote IX connections. And that's where we're not present in that metro when we would acquire a wavelength or a fiber to connect to a remote location. So finally, we come to VPP, or Verified Peering Provider. Essentially, what we wanted to do was give all of our cloud customers a simple alternative to direct peering. That would help mitigate the risk of all the black holes, out of metro failover, and give them that stability they were asking for. We also continue to get questions from cloud customers on which ISPs are best connected to Google and where they actually are connected to Google. So when we launched VPP a year and a half ago, it was actually a limited release, but as of Google Cloud Next a couple of months ago, it's now open for any ISP to join worldwide. And finally, we arrived to where we're at today, which is what I shared in one of the earlier slides. So hopefully the story that we outlined makes sense. As I said, our network saw lots of new traffic and patterns that didn't exist 10 years ago, so we had to adopt and change to meet some of those challenges. So I want to talk about Verified Peering Provider. What specifically is it? I'm sure many of you have heard about it, or not. It's essentially a badging program for internet providers designed to give Google customers an alternative to direct peering by recommending well-peered ISPs for whom they can purchase internet services from. You can think of it as simply as an ISP partnership program that recommends ISPs to cloud customers. So we award the badge in 2 tiers, silver and gold, and it's solely based on the technical criteria and how you're connected to Google. And all of our cloud product messaging, we now redirect all of our customers to connect via VPP instead of peering if they are interested in doing peering. So let's talk about some of the technical criteria. It was very carefully designed to help mitigate the issues that we actually saw and that I talked about. And all of that does go above and beyond our minimum diverse PNI requirements. So for silver networks, they need to peer with us in a single metropolitan area and need to connect in 2 diverse Google POPs for redundancy. ISPs must also have V6 dual stacked everywhere and must not peer on internet exchanges for the reasons I discussed. We also want to make sure we have NOC contacts that are validated, and this is so we can quickly get in touch with an ISP when there's an issue. Sometimes emails and companies change, so we want to make sure that gets updated. For gold, ISPs need to meet all of the silver criteria and then meet us in a second metro area. In that second metro area, diverse PNIs are required, but they can be at the same POP. They don't actually have to be at separate POPs. And all the requirements I state here are the minimum, so any PNIs or metro beyond what's on the screen won't impact your eligibility. So in summary, silver is 2 PNIs in a single metro. Gold, you need 4 PNIs across 2 metros. So let's talk about one of the key pillars of the program, which is actually sharing where Google is peered with all of our VPPs and with what level of redundancy. So the image you see here is a snapshot of what our web page looks like right now. You can see the full list on peering.google.com. We have about 60 ISPs that are enrolled today. So a couple of things about how this page works. So the only metros that are shown on that page is where we have redundant PNIs to Google. So metros where there's only a single connection are actually not shown on that page. And the idea there is we don't want to recommend to customers an ISP who doesn't have redundancy in a metro where their workloads are. Some customers have global workloads, some customers are very isolated to certain locations. You also notice that plus sign next to the metros. That's an indication that the ISP is connected to 2 POPs in that metro. Our webpage actually just had very limited width, which is why we added that plus. But we're looking at ways to more clearly call out which VPPs have metro redundancy going forward. That's been an ask from a lot of the providers who have signed up. As ISPs add more redundancy, they have the choice to update that website and showcase their connectivity. And we do manual updates to the website about once or twice a week. We want to make sure all the images look good and that all the web URLs work. And as I mentioned, it's now open for any network to join. Let's talk about some of the features, right? What do ISPs actually get by joining this program? I touched on some of it, but in addition to the network showcasing their logo, where they're connected to Google, where they offer sales, and a link to their URL, a couple of things to highlight. VPPs do get to use that badge I showed a couple of slides earlier in the marketing material. Some of our VPPs have actually created custom web pages and flyers to showcase their diverse connectivity to customers. This works with any internet products, so dedicated internet, IP transit, and that badge can be attached to those products. We don't charge for the program. It's free to join and free for anybody on the internet to view the list of VPPs. And then we have our ISP portal, which all of our peering partners have access to. So ISPs can go to the site. You can view your eligibility in real time, where you meet and don't meet our criteria. And you can also sign up for it. Right in the portal, there's a click-through 4-step process. You can change tiers as needed or downgrade if you'd like to. And our portal does collect network data in real time, so you can see right now where you actually qualify. All right, so let's talk a little bit about what comes next. So I just gave everybody all of this information, so I wanted to put a call to action to show what it means to everybody in this room or who's actually watching. So first, given all the changes, if you're already PNI peering with us, or qualify for a PNI, nothing is going to change. You can, however, enroll as a VPP. It is an optional program. It's absolutely not required, but it can enable you to get visibility to cloud customers or any Google customer so they can select a well-connected ISP who can give them low latency. It will also help networks who don't qualify for Google peering get more information on which ISP they may choose to access Google. Now, the other question is, okay, well, what happens if you don't qualify for peering and you're not peering today? You can obviously connect through any upstream network that is peered with Google, or you can connect through a VPP, very similar. Obviously, the other answer is to grow your traffic, and then you can qualify once you hit that 10 gig threshold. Now, what if you're an internet exchange? There's a lot of questions here, right? Because we require our VPPs not to peer over internet exchanges, right? So we value the role that IXes play in the community. They're very important. We're connected to lots of them. We exchange lots of traffic there, and so we want to work for them. So there are options for internet exchanges to become a VPP by essentially what we're dubbing as like a layer 3 internet exchange, right? It's essentially an IX that sells internet services or connects to Google, and you would connect in the same way that any other VPP would. So we would do PNI connections and then IP transit, or a dedicated internet access would be an offering. All right, let's look more forward-looking. So what's happening next? So we are continuing to expand Google Cloud to more regions, and so I mentioned more peering POPs will follow that expansion. And we do want users physically surrounding the cloud region to have low latency internet access per our requirements. So we have upcoming regions in Thailand and Kuwait, so we'll have internet peering presences there for connectivity. We also are going to be investing more in the VPP program. So we've gotten a lot of good feedback from cloud customers and ISPs. So we're looking at potentially new tiering criteria related to things like capacity headroom, BGP security requirements, and the availability of our peering connectivity with our VPPs. And then we're also looking to provide more benefits to our VPPs from joining the program. So things like faster support, escalation lists, and providing more data and connectivity analysis to help with troubleshooting and analytics. Similar to what we did with our remote IX connections, we're always looking at our IX and metro footprint to make sure it makes sense for our latest products and what we have today. And then finally, I want to touch on AI a little bit. So its impact at the internet edge is generally still unfolding. With all the LLM work, we didn't see such a large impact on internet traffic, but with things like VO and video generation and the potential for AGI, we're keeping a close eye on what it means for any new requirements that we see. And so that concludes my talk. So I'm happy to take any questions that are online or in person. Great. Thanks, Steve.
Thank you, Dave. We really appreciate the update from you and Google broadly about the changes in the peering situation. We do have a little bit of time. We do have a question?
Yes, we have a question from Matt Petak.
Dave? Dave, apologies. Could we bring you back up? It would seem we have a belated online question.
No problem.
So Matt Petak is wondering, can you clarify how Google measured the 10 gigabit of traffic to determine peering eligibility? Is that inbound, outbound, or both combined? Is it peak or 95 percentile? Does it have to be sustained over a length of time to qualify?
Good question. So it's peak traffic. Egress is generally what we look at. And then as long as there's some peak that we see above that limit, you would qualify for peering.
Thank you.
Hey, John Van Oppen, Ziply Fiber. So we're in the Pacific Northwest, and one of the things that we've noticed with Google specifically is Google's not peering in very many locations. We do have PNIs, but there's effectively no good redundancy because Google is in many locations but doesn't peer in those other locations. So is there an initiative from Google side to add peering locations throughout the Northwest or anywhere in the United States that helps lower latency for customers? We're hauling traffic from Montana and Idaho all the way back to Seattle, which just speed of light delays are pretty significant. The other problem operationally we've seen is PNIs are slow to turn up with Google. I would argue, and I would say both publicly and privately, that of our PNI partners, Google's typically the slowest. And upgrades at the very end of the capacity cycle where it's like, oh my God, we're going to congest kind of scenarios.
Yeah.
And I would love to see Google participate more in going faster at that so we can all deliver stuff to our mutual customers.
Yeah, no, thanks for the question. So your point is valid, right? The example of, hey, our data center's in the Dalles, Oregon, but we only peer in Seattle. Why don't we actually have that, right? So one, obviously, the peering edge is a very big investment we have to make, right? So it's not something we can just drop a router and some backbone. There's a lot of thought and racks and space and scalability that goes into that. But primarily what we look at is that, hey, do we have any requirements from our customers for like egress latency from a cloud region to meet those requirements? And generally the case is that where we are today most likely makes sense, but we always have new customers coming on board. There's always new products being launched. So, if we do have some requirements, it's definitely something we would consider. But at the moment, what I had mentioned about Kuwait and Bangkok, those are the two new locations that we are expanding.
So I'm going to just use Seattle as an example. So Seattle, you're only really in one site. And so there's not even possibility to be a silver category there. And the next closest is more than 20 milliseconds away, just from the peering site to peering site. So it's a significant degrade. I don't know how that impacts your customers, but I would imagine that, from our standpoint, it's caused us to deal with the YouTube traffic in ways that involves hauling it from across the country. Yep. In a failure scenario, if there's like a power outage in the Westin building, for example.
Yeah, it makes sense. Some of the locations, the POP, where Google has a POP is sometimes not correlated to the building. So there may be some buildings that look like one, but there's actually two Google POPs. In some cases, though, you're right. There is only one POP in a certain location, so gold may not be available in that geographic area. That's something we're aware of, but our other metro areas do exist if you'd like to connect with redundancy in line with how the VPP topology requires.
Okay.
Thanks. Oh, I didn't address your PNI question. I want to address that. Yes, sometimes we are very slow. Sometimes it does take a long time. We have a lot of people working on it, and I will say there's a lot of demands on Google networking at the moment, not just peering, right? This is one kind of slice of all of Google networking. So there's lots of AI going on. There's lots of intermetro traffic, right? There's lots of modernizations. And so, ultimately, we're looking at trying to meet all the needs of Google. And sometimes that may mean pulling resources away for slower peering upgrades if we have other demands. But we are looking at things to speed that up in the near future.
Yeah, to me, I would comment that it wasn't that they didn't respond. It was that troubleshooting, say, an Equinix cross-connect that was ordered by Google took 5 rounds with somebody who clearly had never looked at a cross-connect before. So, and we're expending energy too, so it's not a one-way thing. Like, we're providing our side and putting a senior engineer on the ticket. Like, it just, from my standpoint, would love it to be mutual.
Yeah, no, we appreciate the feedback. Thank you.
An online question from Ryan Hamill. Do the announced changes in peering policy also apply to Google Fiber and WebPass?
No, Google Fiber maintains its own peering policy as well.
Thank you.
Once, twice. Cool. All right. Thanks.
Thanks again, Dave.